Hi, greeting everyone. So today I will show the generation of narrow-band frequency modulation, or we call it as an NBFM. So as we know, we have two type of frequency modulation, which is NB, narrow-band FM, and the other one is wideband FM. So the difference between NB and wide BFM, that narrow-band FM has a smaller bandwidth compared to the wideband FM. Narrow-band FM bandwidth is similar with amplitude modulation bandwidth. So today I will show how we can generate the narrow-band frequency modulation based on mathematical approach. So in this system consists of phase shifter, 90-degree phase shifter, multiplier, integrator, gain, and also the last node is summation node, adder node. In any modulation circuit, we need to have at least two input, which is carrier signals here and modulating signal here. Okay, the first process for a unmodulated carrier signal here is directed to the phase shifter. So what happened here? So VC cos 2 pi FCT having a 90-degree shift means that the cosinus wave become sinusoidal wave. VC sin 2 pi FCT in here, in this point. Okay. The carrier signal also is directed to the gain here. So become, at this point, the amplitude of the carrier is amplified by a factor of 1. See, cos 2 pi FCT. Whereas the other parameter such as phase and frequency carrier is preserved. So for a modulating signal, VMT here, so VMT is routed to the integrator. This is an integrator block diagram. Let's say this one at point A, okay, A, point B, and point C. So what happened at point C? Point C. So integrator VMT is integrate with respect to dt. So become 2 pi KFVM, okay, cos 2 pi FMT integrated with respect to t. So here become 2 pi KFVM cos integrated with cos integration of cos become sine, right? So sine 2 pi FMT, so over 2 pi FM. So we can simplify this equation as KF FM VM sine 2 pi FMT at point C. So at point C here. So let's say what happened at point D when phase shifted carrier is multiplied. Phase shifted carrier here is multiplied with a integrated modulating signal. Means that A times with C lah. A times with C, we got D. Okay. So at point D, here, we see sine 2 pi FCT times, so here we can be KF over FM is a what? It's a beta, right? So beta F sine 2 pi FMT, index modulation of FM. Okay. So VC sine 2 pi FMT times BF sine 2 pi FMT here. Okay. So here we got sines, signals, times sines, signals. So let's say this term is A and this term is B. So we can use a trigonometric identity to solve this term or to simplify this term. Okay, this term. So sine A times sine B is equal to the half of cos A. Cos A minus B plus cos B minus A. Okay, so we apply the trigonometric identity here to this equation. So at point D, at point D, we see sine 2 pi FCT times beta F sine 2 pi FMT. Okay, so we use the trigonometric identity, so these things become VC times beta F over 2 cos 2 pi FC minus FM T minus cos 2 pi FC plus FM T. Okay, so this equation is the result of A multiplied with C. Okay, so at last we add point from the output from multiplier with the output from a gain here. So means that, let's say here is E. So E is the output of B plus D. Okay. So at point narrow band. Okay. So at point E, which is output of multiplier times with output of gain. So output of multiplier here. So output of multiplier VC times beta F over 2 cos 2 pi FC minus FMT minus cos 2 pi FC plus FMT times or added. Sorry, ini added, right? So added. Summation, so sorry, add with A1 times VC sine cos 2 pi FCT. So point E is output of adder, right? It's output of adder. So plus lah, okay. And at point D, output of multiplier. Is that? Yeah. Okay. Okay. So we can observe this equation, the resultant equation at point E here, the last point of this system. So the first term here, let's say we call it first term, second term, and third term. Okay. So first term is actually consists of frequency spectrum of a frequency component of FC minus FM, which is we can relate it with a lower side of frequency. And the second term relate with FC plus FM and related to upper side. And FC is a component frequency for a carrier. So looks familiar? So actually this one we can assume that this component of frequency looks similar with TM. Right. So when we view this signal through a spectrum analyzer, we can see that the display of this frequency analyzer. So we got something like this one. Right. Right. Okay. Okay. So here, when we draw that frequency spectrum, so amplitude of carrier A1 times VC. So how many strong a VC depending on A1 lah. Kalau A1 if in a greater value of greater factor than VC, the power carrier should be very, very large. So this one FC carrier, and this one is FC plus FM for the high side or upper side, and this one for a FC minus FM for a lower side. So this one is actually narrow band FM. Why? Because the bandwidth is Same with amplitude modulation. So bandwidth of narrow-band FM equal to 2 times of FM. Okay, so 2 times of FM. So same with bandwidth of AM. So this is how we generate the narrowband FM using a mathematical approach. And to generate the wideband FM indirectly from the narrowband FM, actually we just need some device, some block diagram function here, as we call it as a N multiplier. So N multiplier, the function is to spread out the wideband. Okay, so from here we got wideband FM. Okay, so that's all for the generation of narrowband frequency modulation. Thank you.